Hi everyone, so now this is the very last bit of trigonometry. So far we've done finding the side length of a triangle, finding a missing angle in the triangle. Hopefully you've done the worded questions. Now it is sort of the idea of having two triangles stuck together. It's not really that much more difficult than just the normal trigonometry that you've been doing. It just looks quite a lot harder, I think. The really important thing is just to see that there's two right angle triangles. For the worksheet that you've got to do is labelled x1 and x2, which makes it really easy. Find x1 first and then find x2. So for this triangle we're going to be finding this value first. Once we've found this value, we're going to use this to help us to find this one up here. So you're finding one value which helps you find the other value. So you start off by labelling the sides in the triangle like we've done before. So x1, because it's part of this triangle and this triangle, it's the side that's shared by both. What you do, the general rule is to use the triangle which x2 isn't in. So for this one, x2 is in this triangle, so we're going to use this triangle first. This gives us the information we need to find x1, as you'll see now. So if we label the sides, so next to the 35, this side is the adjacent. Opposite the 90 degrees, this side is the hypotenuse. We can then, so A and H, look at the top, A and H is cos, so we can write down cos theta equals A over H. Cos theta is the angle, so cos 35 equals adjacent 10 over H, which is x1. This is the sort of slightly harder example that you've got to times by x1 to the other side. So x1 times cos 35 equals 10. And then you've got to divide by the cos 35. Divide both sides by the cos 35 to get 10 over cos 35. So x1 equals, type that into your calculator and you're going to get as an answer 12.21. Okay, so that's x1. We can now write that, if we want to, into this diagram. Now we need to do the same but for the second triangle. So for the second triangle, we've got the O, the A and the H need to be redone again. So it's like starting from the beginning again. So it's easy for me to just get rid of these lines. So we've now got to go for the second triangle. You've got opposite the side, so 12.21 is opposite the angle, so that's O. x2 is opposite 90 degrees, so that's H. So for O and H, we're going to be using O and H, so we're going to be using sine. So sine theta equals O over H. So sine of the angle for this triangle at 62 equals the opposite, which is the 12.21 you just found, divided by the hypotenuse, which is x2. Similar setup to this one here, where the x2 is on the bottom. So now rearrange it, times both sides by x2 to get x2 times sine 62 equals 12.21. So x2 divided by the sine 62, 12.21 divided by sin 62. So x2 equals, so 12.21. Just a note, on my calculator I've still got the answer from this question left on there. It's left on there as a full whole number without any rounding. If I use that answer, I can use the A and S button on the calculator and it will just use that previous answer, or just simply divide by the sine 62 and it will be completely accurate. So divided by sin 62 and gives you the answer as 13.8 if you write it to one decimal place. So 13.8 for x2. And that's pretty much it. It's pretty much the same every time. What changes is you'll be asked to find maybe an angle, or you'll use tan or different letters as well, different sin or cos as well. So this is one where you have to find the angle. So Again, you're going to find x1 first. x1, remember the triangle that hasn't got x2 in, you're using that one first. So the triangle without x2 in, the right angle triangle without x2 is this one here. So we're going to be using that one first. Find x1. You've got opposite the angle, that's O. Opposite the 90 degrees is H. O and H, hopefully now you know, is sine. So sine theta equals O over H. Sine theta, so the angle is 62, so sine 62 equals your opposite, x1, divided by your hypotenuse, which is 30. So this one is the easier type. The 30 becomes a times on the other side, or times both sides by 30. So you get 30 times sine 62 equals x1. So 30 times by sine 62 gives you an answer of 26.49. That's x1, it's 26.49. Okay, once we've got x1, we then need to do the find x2. So now looking at our other triangle, so we don't need these labels at all anymore. They're not useful. You can still leave yours on rather than rubbing them all off, obviously. We now know that x1 is 26.49. So that's that length of that side now. Now we're going to look at this second triangle. So opposite x2 is 12, so that's the opposite. Opposite the 90 degrees is the hypotenuse, so it's O and H. So we're using the sine. So sine theta equals O over H. Sine of the angle, and the angle is x2. We don't know what the angle is, that's what we're trying to find. That is the opposite, 12 over the 26.49. Then do the inverse sine, so sine minus 1, 12 over 26.49. Type that into your calculator, so shift and then sin, and then you do the fraction 12 over, and then you can use the A and S button again, or you can type in the 26.49 if you want to. And that gives you an answer of 27 degrees if we round it to the nearest degree. And that's all there is. That's trigonometry completely finished now, until we do stuff with 3D at some point in year 11. But that's as far as we're going to go in year 9. So well done everyone for getting to the end.